also watch the video, so, you know, here we are. Alright, so a system of equations is two or more equations and what'd y'all say, Slytherin? What words did you put?
That equal each other.
That can equal each other. All right, does anybody think they know what a solution is? Raise your hand, don't scream. All right, Gryffindor?
My name's Carly. She said your name is Dumbledore.
I did not say her name is Dumbledore.
What'd you say?
Gryffindor.
Oh.
My name is Carly.
We said, what did you say, Patrick?
So Patrick said.
Yes.
Patrick so, the solution is what they the numerical value of what they equal.
Yeah.
What's a they?
The equations.
Okay.
Yeah.
Bo, give yourself 2 points. Bo Batten, do y'all have anything to add for a point?
Yeah, but okay.
Yes. Do y'all have anything to add to solutions for a point?
Yeah.
Alright, so a solution is the numerical value or point values. Let's make that plural because point has 2 coordinates. So the numerical value or point where, that satisfies both equations. And we've seen that in table form and graph form. So what does it look like on a graph?
When they
cross, when they intersect, all right? What does it look like on a table?
when they're equal.
When what's the same?
Or the equal. When the x and when the x is the same. No, the y is the same. The x and the y.
The x and the y, yes. The whole point is the same. All right, so today this is going to be page 35. If you want to add that to your table of contents. If you don't want to get that out at the moment, we can add that at the end. Don't worry. So this is page 35. I love systems of equations. It's just lots of fun. There's all kinds of things we can do with it. We can use it in word problems. I can give you different kinds of equations. It's just amazing. So we have 2 learning targets for today. Our first learning target is just a level 1 learning target that says, I can identify a system of equations. Now, someone at the Hufflepuff table, please tell me how you think we could turn that from a level 1 to a level 2. Or level 3. I can graph a system of equations. All right, give yourself a point. Does anybody think they can do it a different way? Or level 3. There's also a chart back here. All right?
I can construct a system of equations.
All right, give yourself a point.
Hold up.
If you already have 1, that moves you up to 2.
What if?
All right, so our next learning target says, I can determine I gotta get a new marker. I can determine the solutions, one solution, to a system.
By graphing.
Does it say by graphing?
Yes.
Oh, awesome. Let's put that in parentheses because we may do a little more than that. So do you think that the second learning target, is that level 1, 2, or 3?
2.
At least 2, correct? Why do you think it's at least 2?
Because I said determined.
Because it's graphing and it said determine. Could we also make that a level 3 though?
Yes.
Easily. It just depends on what kind of problem we're doing, right? So our first example that we're going to do, down here at the bottom. Is everybody ready? Is anybody not ready? Okay. Okay. So what do you think we're going to do with this system to find the solution? We're going to what?
Plug it into the graph.
Plug it into the graph. We're going to graph them. So I'm going to graph my first one in green. So this guy is going to be green, and this guy is going to be pink. And I suggest that you use 2 different colors so that you can differentiate between the graphs. I highly, highly, highly suggest that when we graph these, you use 2 different colors. She's just hogging them, isn't she? Keeping all those markers for herself. Do y'all need some more markers? Okay. Y'all need one of each color? Right.
So it's a level 3.
So it's a level 3. What are we differentiating? What are we differentiating? The different equations? What about the different equations?
We're trying to see where they intersect.
We're trying to see where they come. Alright, so how would we graph green? The first one, y equals x minus 2. What would we do?
Well, you can plot -2 since that's the y.
On which axis?
The y.
So we need to label our axes, correct? So we're going to go down 2, put a dot. What would we do from there?
Up and over.
Over where? Over is not a direction.
Right.
Could we also go down 1, left 1? And we know that this is a positive graph because we're climbing up the hill to the field of marshmallows. So the solution when we're graphing is where they cross. So we're trying to find where these 2 graphs meet. Are we ready to graph pink, or do we need a minute? Okay. Are we ready now? Alright, so how would we graph y equals negative 2x plus 7? Go up 7 on which axis? The y. So we go up 1, 2, 3, 4, 5, 6, 7. Alright, and then what's our slope? So down 2 and then
Right 1.
right 1.
You don't go over anything.
Because we're not cows, remember? Down 2, right 1. Down 2. Oh my god, they crossed. They hit each other. We killed it. It's Battleship. We sunk it.
No way.
Look at us go. I know. I love systems. Alright, what is the solution to this system? 3, 1? That's what I'm talking about. Give yourself a point over here. They said it first.
We said it first.
Right, so that's not first.
I honestly thought I was also thought that was
What? I'm sorry. I just thought of something real funny. Nope. Alright, so any questions on what we did to begin with? I don't know. Alright, let's go to the next page. The solutions page. So here we're just going to identify what these solutions are. Easy peasy lemon squeezy. So, our first solution, right here. Bow-Battens, for a point, can you tell me what that solution is? I want you all to tell me what the solution is for a point. I said Bow-Battens. That table back there.
Bobat sounds like bow round.
I'm proud of you. I really am. It's crazy what's easy when you come to school.
Yeah, why did you miss so many days?
4-8. Do we agree or disagree? We agree. Give yourself a point. Yes. All right, Ravenclaw, because y'all some psychos over there.
You just circling or something?
Yeah. All right, Ravenclaw, tell me what that point is.
-7-3.
Do we agree or disagree? All right, give yourself a point. What is wrong with you?
Wait, is this part of page 35?
Yes, this is 35B.
So is this going to be like A, B, C, D, E, F, G?
No. But this is B. Alright, so now we need to figure out what it is on a table. Now they gave us the x values. They gave us our different equations. We need to figure out where the solution is on the table. Alright, Hufflepuff? 2, -11. Do we agree or disagree? 2, -11. Alright, give yourself a point.
I got the next one.
You've already answered. Alright, Gryffindor. For a point, tell me what y'all got for this next one. -312. That's what I'm talking about. Alright, so those are pretty easy, correct? So if I slap these on a graph in front of you, huh?
Whoever that's on best sheets. Yay.
No. Get it together. Again, what class is this? Right. Alright, so what we're going to do now is we're going to take our skills of finding our solutions and we're going to apply it to graphing. So this is going to be page 36 in your notes. Yay! So the first two pages were 35A and B. This is going to be page 36. And in your table of contents, it's going to be called Graphing Systems in your table of contents. Alright, so if you need to see my table of contents, there it is. Austin, I like your hair now that you're growing it out with its wavy craziness.
Yeah, he grew it out while he was in school.
Just think, if we didn't care, we wouldn't say anything.
What if we didn't even notice you missed that many
You
things?
are?
Kind of bad.
You are getting a face.
Yeah.
He's getting a what?
A face.
Oh, okay.
You don't know what face is?
I'm pretty sure she do that.
I think, yes, you do. You know what face is.
That's not why I'm making this face.
Yeah, it's because it's different.
Alright, so graphing a system. Step one. You solve each equation for y. So when you graph it, it has to be in slope-intercept form. So let's make a note beside this that says slope-intercept form. Alright, looking at our system, and the way you write systems is you write your two equations and you put a squiggy beside it. Yep.
Like that little S and Z.
S and then 2. Write an S and then a 2.
Oh, I thought it was a Z. It can be a Z.
It can be whatever you want it to be, Pumpkin.
I
But it doesn't make sense for it to be an S and then a Z.
Yo,
Because your Z goes like that.
what you mean? It don't matter. It's still.
But then it looks
It still
janky.
look like a squeaky.
It doesn't. Alright, so step 1 is to solve each equation for y. Now, are both of these solved for y?
A two look the same way. But
Oh my sweet potatoes. Are both of these solved for y?
No, ma'am.
The first one is not solved for y, so we are going to do that together. Now, I'm going to do this one in green. So, I don't know why, I just really like green today. So, let's come over here and write 4y minus x equals 16. Now, this is where our practice with literal equation comes in, where we have been solving for a variable. This is the whole reason, so that we can solve equations. I'm telling you, put it all together. It is, that's why I said that. Alright, so now, we are trying to solve for y. That means that we need to get everything away from it. So how would we move that x?
Mine is plus
Alright, that's what I'm talking about. It's like I've taught y'all something. And x plus, I hope so. X plus 16. Now, the reason I wrote my x first is because it's in slope-intercept form. Yeah, remember y equals mx plus b? Okay, now what would we do from here? Oh. Divide by what?
4.
That's a point for us.
That's a point. It was our budget.
Not yet. Now, it will be a point if you, Ravenclaw, can tell me what our simplified express or the
Y
potatoes.
equals 1/4 x plus 4.
That's what I'm talking about. Give yourself a point. All right. So now we have step 2 is to graph on the same coordinate grid. The same coordinate grid. The same one, babies. The same one, because they got to cross. And if you graph them on 2 different, they're not going to cross. So I'm going to rewrite, and I'm going to graph my other one in light blue. I just rewrote, so I came down here, and I rewrote my system with both of them in slope-intercept form right here. That's all I did, was I rewrote my system in slope-intercept form.
That's a big sweetie.
I know, I like to party. Alright, our first one. How would we graph it?
Go on the y-axis. Wait with your axis first. That's the point. That's the point.
Alright, Slytherin, how many points y'all got over there? 1? 2? 3? Okay.
Wait.
Y'all got 2?
Yeah.
You're only supposed to have 2.
We have like 0.
You're such a liar. Alright, so Hufflepuff for a point. Tell me what to do. There we go. Now you've earned your point. Bo Buttons, tell me what to do next. Up 1, right 1, 2, 3, 4. Give yourself a point. Up 1, right 1, 2, 3,
But you
4.
just keep circling the same thing?
No. Oh, that's a Nick.
No, because you said
Oh, that's
give
a
him one.
Nick.
You said give him
Oh,
one.
that's a Nick.
And you ain't had- I
Mine
asked
is
you
the
the first time. You
That's
said-
Minus 5 points.
That's fine too.
No, that's not. You can keep circling the same thing. With your,
Oh, is she?
Because I'm going to remember that later. Whoa. Whoa. Alright, I need to graph and... Like you're trying to kill somebody over there. Alright, so draw your line.
Hey. Hey. Hey.
Connect your dots.
Oh, Miss Asbury.
How you doing? Alright, how would we graph the next one?
Start with -1.
-1.
Woo! And then what would we do?
Up 3, right 2.
I need a point. I know where
Up
the
3, right
intersection.
2.
It's 4, negative 4, 5.
Oh, I found
4,
it.
5. 4, 5. I get the point first.
Alright, so, do they cross at a point?
4 or 5 is the point that they cross over.
4 or 5.
That's the point for a point.
Yes, take your point. Y'all need to start being as annoying as them, and then you'll get a point.
Annoying.
We're enthusiastic.
That's very true. You are enthusiastic. Alright, are you ready to practice on your own? So I'm going to write a couple of systems on the back. There is graph paper in the 4th drawer. What does step 3 say? Look for the point of intersection, and our point of intersection was 4, 5. Alright, so you have graph paper in the 4th drawer of your tower. I'm going to write a couple of systems on here, on the back, and you are going to graph them and tell me what the solution is. Are you ready? Please stop that. Please stop that. Stop that.
You know what this is?
No. I'm not a weirdo.
That's not weird.
You're a weirdo. Alright, so problem A. Let's go crazy.
Oh, that was too crazy.
With my X's and Y's.
Damn hard. Come on.
Bunch of babies.
That's what I'm saying. Get your point back.
Enthusiastic.
For not being babies.
No,
Yeah.
for helping others.
And I'm gonna give you one.
Truth.
I don't even know what that
I don't
Who is Hufflepuff?
They are Hufflepuff.
Are we trying this then?
What are
Tomorrow.
Beauvais?
Beauxbatons, it's the school in France.
What does that mean?
It's a school in France.
Do they do anything
Which one did Harry?
They learn wizardry in France.
That's not
Wizardry.
You gotta move hands.
You went to Gryffindor. Oh, you went to Gryffindor?
Who?
Harry Potter.
Harry went to Hogwarts and he was sorted into Gryffindor.
Oh, you was.
Oh, yeah, boy. That's us.
Yeah, Patrick.
He did almost get sorted into Slytherin.
Is Ravenclaw the best one ever?
I've never watched Harry
You're missing out on life.
Potter. I've never watched Harry Potter.
You were missing out on life, I'm telling you.
Harry Potter.
I think I remember watching part of one game, like when they